Hello students, welcome you all. Now in this lecture I will tell you the E2 elimination reaction in substituted cyclohexane. In my last lecture I told you about the different features of E2 elimination reaction and different examples where regioselectivity, stereospecificity is possible. Now let's take the examples of substituted cyclohexanes and what should be the main requirement that this cyclohexane or substituted cyclohexane should have so that E2 elimination may take place. One of the main important feature of E2 elimination was that the leaving group or halogen group that should be anti-periplanar to the hydrogen atom or beta hydrogen atom. And second thing that I told you, okay, so one thing again here also, the leaving group should be anti-periplanar to the beta edge, anti-periplanar to the beta hydrogen atom. And second thing here, if we are dealing with cyclohexane ring or substituted cyclohexane, then the leaving group or the halogen atom that should always be, if you are writing the product, then the leaving group that should always be in axial position. Okay, so the leaving group in cyclohexane chair form. So if we are dealing with cyclohexane, then better to write the reactant molecule in a chair form, because we know that the chair form being the stable form, then we should always write the cyclohexane ring in a chair form to get the correct product. Okay, so the leaving group in cyclohexane chair form should be in axial position. Now if you see, axial position means either it is vertically above or vertically below in the chair form. Now suppose if leaving group in cyclohexane ring is, if you see it is present in an equatorial position, then we know that the cyclohexane chair form has a tendency to flip. That's why we should flip it so that the leaving group comes into the axial form. So one of the important things, suppose if the leaving group is present in axial form, in equatorial position, then we should flip the chair form. We should flip the chair so that leaving group comes into the axial position. In that case, the leaving group will come into the axial position. Okay, so now let's understand these things with the help of example and with the help of model also. Now one thing that I should suppose if we have this model of this cyclohexane. This is a cyclohexane, and you can see, if you see this cyclohexane, you can see this, it is in chair form. Okay, this is in chair form, and you will see this cyclohexane now, this is coming into the boat form. So we know that this cyclohexane, it can exist in a stable chair form, then in boat form, in twisted boat form, in half chair, in this half chair form also. So this is the boat form, and you will see this is the chair form. And again if you will see, then this is the half chair form. This is the half chair form, but half chair form is not a stable form. Okay, so as you can see, it will come again, it will come back to its either chair form or boat form, because half chair is not so stable one. So this is the another configuration, that another shape that you can get. Suppose this is the chair form, and another that this form is the your twisted boat form. This is your twisted chair form. Okay, so like this. So we are concerned with the chair form of the cyclohexane ring, which is the most stable form. This chair form is being the most stable form. And now if we will see, then here this bromine atom is in a axial position. This bromine atom is in axial position, and what I told you, E2 elimination, if you want to see the E2 elimination, if you want to do the E2 elimination in cyclohexane, then the bromine atom that should always be present in an axial position. Then only you can do the beta elimination. Okay, so for beta elimination, another main thing, that the leaving group should be anti-periplanar to the beta H. Now if this is your alpha carbon, then beta carbon would be, this is your beta carbon, and next beta carbon, this is the another beta carbon. So this is the beta carbon, and this is also the beta carbon, and from this both beta carbon the hydrogen can be removed. So which hydrogen that would be removed? The hydrogen which is anti-periplanar to this. Now suppose if you will see, then now let's see this beta H and this alpha carbon and this beta H. Now here this hydrogen can be removed, because these two hydrogen and this halogen, these are anti to each other, these are opposite to each other, and they are also 180 degree to each other. Dihedral angle you can see 180 degree. In the same way, suppose if you will see this beta H, then this beta H can also be removed. If you will see, now this beta H can be removed. So this halogen atom and this is your beta H, this can be removed. Okay, this can be removed because they are perfectly 180 degree to each other. Now suppose this is not in this axial position. So what I have written the condition, the leaving group in cyclohexane chair form should be in axial position. So here this is in axial position. Now suppose it is coming into the equatorial position. Now whether we can remove, let's see it. Now what I have done, now if you will see, now this bromine atom is now present in equatorial position. This bromine atom is now present in equatorial position. Now let's see whether we can remove the beta H here or not. Okay, so if this is your alpha carbon, then this would be the beta carbon, as well as this would be the beta carbon. Two beta carbon are there and hydrogens attached to this beta carbon, that would be the beta hydrogen atom. Now whether here to this beta hydrogen can be removed or not, these beta hydrogens can be removed or not, for this condition is that they should be anti-periplanar. So if you will see, this is your bromine atom which is away, which is in equatorial position. So to this equatorial bromine, there is no periplanarity with the beta hydrogen. So because this is going in this way, this hydrogen is here and this hydrogen is here. The angle is to this beta H, to these two beta H, the angle the dihedral angle is never 180 degree, or we can say this bromine atom and these two beta hydrogen are not exactly opposite to each other, are not present at 180 degree to each other. In the same way, so this cannot be removed. So beta H cannot be removed because the bromine atom is present at the axial position, present in a equatorial position. In the same way, if you will see here, this is also a beta hydrogen. Now here also, if you will see this bromine atom and no two beta H are present, at 180 degree to each other, or they are not anti to each other, or they are not anti-periplanar to each other. So that's why we cannot remove. So if these are in, if bromine is present in the equatorial position, we cannot remove the beta hydrogen atom. That's why what we can do, what I have written, that if the leaving group is present in equatorial position, then we should flip the chair. We should flip the chair that can be flipped. So what I will do, I will flip it. So here, if this is below, if this carbon is below, then it will go, and these two carbon are above. These two carbons are above in comparison to this carbon. So what will happen if we will flip it? If we flip the chair, then carbon which are above, they will go below, and this carbon which is below, they will go above. So let's flip the chair. So flipping is not like this. This is not flipping. This is not flipping. Flipping that like this. So now you will see this is going above, and this chair will go like this. Now in this position, if you will see, this leaving group is coming in in axial position. Okay, so this is the flip of this chair. Now we can remove the beta H. Now we can remove the leaving group also. We can remove the beta H. So let's take some example and we will see. Okay, so if you see, take one example. Now suppose if this is our substituted cyclohexane, and if we have a strong base sodium ethoxide, and if we provide the heat to this reaction, then what would be the product in this case? So for this, what I have told you, to remove the beta H, because to remove this leaving group and beta H, we should better to write this one in a chair form. So this is our alpha carbon, this is the beta carbon. In the same way, this is also the beta carbon, this is also the beta carbon, and this is also the beta carbon. This is also the beta carbon, and these are the different beta carbons which are present. Okay, so only that hydrogen can be removed which are anti-periplanar. So that's why what we will do, we should write it in a chair form. We should write it in a chair form, and for this let's okay. So suppose we may give the numbering also. Suppose this is number 1, 2, 3, 4, 5, and 6. Now, so if you will see, then at this beta carbon, the hydrogen which is present, where the hydrogen is present, no doubt you will write the hydrogen in this way. You can write the hydrogen in this way. Here, if you will write the hydrogen, so one of the hydrogen, no doubt, one of the hydrogen is present like this. This is one of the hydrogen, and this is the another hydrogen, which is one of the below and another is the above. Okay. Now in chair form, suppose if this is given number 1, if this is given number 1, if this is given number 2, this is given number 3. Okay, this is 4th position, this is 5th position, and this is our 6th position. So at first position, bromine is above. I am writing the bromine above the plane, and this CH3 is below. So CH3 is below. At second carbon atom, CH3, one CH3 is above. So this CH3 you can write, you can see this CH3 is above, and one of the hydrogen is below. Hydrogen is below. So this is the hydrogen. Third position, this is 3rd, 4th, 5th, and let's come to the 6th position. At 6th position, one of the hydrogen is below. This hydrogen is below the chair. This hydrogen is above the chair. So like this, this is the hydrogen. Now you can see. This ethoxide ion can remove the beta H or anti-periplanar, so that only when they are anti-periplanar. So this can remove this hydrogen and it will form a double bond like this. So this is one of the possibility that this hydrogen can be removed. Another possibility is that this is also anti-periplanar. If you will see, then this is also anti-periplanar. This is also antiplanar and this is also anti-periplanar. So this hydrogen can also be removed. So means either this one or this hydrogen can also be removed by this base. So what would be the product? So if we write the product, then we may write down now, and the double bond that would be formed, okay, so double bond should be formed between 1 and 6, and one of the suppose this is our first one, this is second one, third, fourth, fifth and sixth. So double bond is present between first and sixth, and at second position one of the methyl group is present at the second position. So this should be the product. This is one of the product. And now suppose double bond is present between first and this one. Suppose double bond is present between first and second carbon. The another product that is formed, this is the one product, and the double bond is present over here. Sorry, the double bond is first, second, third, fourth, fifth and sixth. Double bond is present between first and second carbon. Okay, so out of this two product, which one is the correct one? Which one is the correct one? So if you will see, then this is the most substituted product, this is less substituted product. So this is the ZF product, and this is our ZF product, and this is non-ZF product. This is non-ZF product. So the product that is correct one is this one, or we can say this is the major one. This would be the major product and this is the minor product. So we will get the stereoselectivity here. So we are getting the stereoselectivity here, and plus no doubt this ethoxide ion is removing the proton, so it will also give the ETOH that would be formed, and this bromide ion is left out, and we have the sodium ion in the solution, so that should means NaBr that should also be formed. Okay, now what I told you in my previous lecture of E2 elimination, this substrate may be either primary, secondary or tertiary. Halide may be sites primary, secondary or tertiary. So but SN2 reaction in tertiary halide SN2 reaction doesn't occur, whereas here if you will see, this is also the tertiary halide. This is our tertiary halide, and this tertiary halide will give the E2 product. It is giving the E2 product, but it cannot give you the substituent SN2 product. This will not give you the SN2 product because this is the substitution is taking place here, because here the E2 is taking place in presence of heat. E2 will occur. Okay, so this is the product which is formed when bromine, you can see, is present on the axial position. Bromine is already present in the axial position. Now suppose I write the bromine in equatorial position. Okay, here bromine is above, means this is in axial position. Okay, suppose I write the bromine in a equatorial position. So let's take another example. So if I take another example where you will see the bromine is present at here. So this is the bromine. Okay, and if bromine is present over here, and suppose the hydrogen is present over here, 2 hydrogen is present over here. Now what should be how you will write the product? Now you can see these bromine and hydrogen, they may be anti to each other. They may be anti to each other. One is going below, another is going above. They are anti to each other, but they should be anti-periplanar also. So they should be anti-periplanar. For this you should write its shear form. So we can write its shear form, then it would be better understood. So suppose this is first carbon, second carbon, third, fourth, fifth and sixth. I am giving such naming. Suppose I am giving such naming, and if you will see, then bromine is present at the equatorial position. Whereas suppose this is first one, this is second, this is third, this is fourth, fifth and this is sixth. And at second position hydrogen is present above. This is the hydrogen which is present above, and suppose I am writing this hydrogen, and here this hydrogen is also present above at sixth position. Here this hydrogen is present above sixth position. Already I have shown you that if the bromine is present in equatorial position, so suppose this is the bromine, and if you see this bromine is present in equatorial position, then in that case we can never remove the beta H, because they are this beta H is not periplanar to this bromine atom. So that's why what we should do, to write the product we can flip, or the cyclohexane in its shear form it may flip. So we can write the flip structure. Of this. So what will happen? This above, the carbon which is above, that will go down, and the carbon which is below will go up. So we can write this in this way. We may write it in this way. So this carbon is going up. So this is going up, and this will come down. So this will come down. This will come down like this. So here, now this is our bromine. This carbon has come down. After flipping, this carbon has come down. This has gone up. So this is our first carbon. This is suppose second one, and suppose this is, I am writing third, fourth and fifth, and suppose this is sixth one. Okay, so now at first one, bromine is below. So I am writing below. Bromine is below. This is bromine, and hydrogen at sixth one is above. Hydrogen at sixth one is, you can say, hydrogen at sixth one is above. Hydrogen at second one is above, also above the plane, above, that is the axial form. This is also above like this. Now you will see, now you can see the bromine and this hydrogen are now in antiplanar fashion. This bromine and this hydrogen is now in antiplanar fashion. So here the removal of this may be possible. So what product that can be formed? The product which is possible is, suppose now this is bromine, and this is first carbon, second, third, fourth, fifth and sixth. So the double bond may be formed between first and second, or first and sixth. So this is one of the product, or we may write the another product. This is first and sixth. We may write this one as this. So but both are the same thing. So here what we have seen, if the bromine is not present in the axial form, so to write the correct product, we should first write it in a shear form, and then we may proceed for the product. Okay, so let's see another example. So in the next example, if you will see, again if I put the bromine or the leaving group in your equatorial position, if I put this bromine in equatorial position, and suppose if one of the hydrogen is present over here, and another, this is one of the hydrogen, and next hydrogen which is present, this is another hydrogen. Suppose this is another hydrogen, and this is our CH3, and like this. Now, so what should be the product if we are treating with sodium ethoxide? Then what should be the product in this case? Now again, you can see, if we will write it in shear form, and if you number it 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and this is 6th. So bromine at first position is below. At first position is below. Then that should be written in this way. At 6th position hydrogen is above. So we will write hydrogen in this way. And at 2nd position the CH3 is above. This is our CH3 and hydrogen is below. Hydrogen is below. Now if you will see, then because the bromine is present in, because the leaving group is present in a equatorial position, that's why you cannot write the product, you cannot see the anti-periplenarity anyway. So that's why what you will do, you will write, you can flip it. So we will flip it. So if we are flipping it, then what will happen? Okay, so this bromine, suppose this is our first position, this is now 2nd position, 3rd position, this is our 4th position, okay, this is our 5th position and this is our 6th position. So at first position bromine is down, so if bromine is down you may write it down at this bromine is down, and at 2nd position the CH3 is above, CH3 is above at 2nd position and hydrogen is down, so this is down, this is CH3, and the 3rd position and at 6th position you will see the hydrogen is above. 6th position the hydrogen is above that. So that's why, so if you will see now, if we want to see that if your base is coming, then this ethoxide ion that will remove this hydrogen, and here the double bond will come, because there is no anti-periplenarity between this bromine and this hydrogen. The only way to remove is this. So this would be formed as a product. So this would be formed as a product, means the double bond that would be formed between 1st and 6th carbon, between 1st and 6th carbon only, and we will get this product here. We will get, and 2nd position we will have the CH3. So if we are removing the or why this is not formed, this product will not form. This product will not form here. This product is not formed, though this is a ZSF product. Though this is a more substituted product, but this will not be formed. So here you are getting the non-ZSF product again. Here you are getting the non-ZSF product. Non-ZSF product we are getting, which is the less stable product, is formed in a more amount. So less stable product will be formed in more amount. So this is an example of stereospecificity. Only one product which is formed. This is the only one product. Okay. Otherwise, another product may be formed from from this carbon. The hydrogen may be removed from this carbon. Sorry, only from this one. Okay. So from this one only. Okay. So here the stereospecific product is formed. Now suppose I take another example. If I take the next example that we may take is, suppose suppose this is our bromine atom. Okay, so this is the bromine atom, and if this hydrogen which is I have written here in this form, suppose I write it like this. Here the hydrogen is below, the hydrogen I have written here, and now this CH3 is like this, and it's both hydrogen. Now what would be the product in this case? Now what should be the product in this case? What should be the product? What should be the product? Okay, so no doubt both this hydrogen are anti to each other. So if this is our beta, this is our beta H, and this is also beta H, this is the alpha carbon. Okay, so then here both hydrogen can be removed because both are anti to each other. But better, first we should write it in a chair form. And here this is bromine atom, this is above, and this is our hydrogen is present over this position. Sorry, the hydrogen is this is our hydrogen and the CH3 is below, like this. But we should flip it. We should flip it because bromine is below. Because bromine is below, that's why we should flip it. And after flipping it, we may write the product like this. Okay. Now this bromine will come here down the position. So this is first, and this is second, third, fourth, and this is sixth. And this is first, second, and this is our third. This would be fourth, and this is fifth, and this is sixth. So at second position, hydrogen is above. So I can write hydrogen above. CH3 is below. CH3 is below. And at sixth position, you can see this hydrogen is above. This hydrogen is above. Now in this case, if you will see, then both beta H. So this is one of the beta carbon, and this is also the beta carbon corresponding to this. So both can be removed. This can be removed either, or this may also be. So double bond may come in between first and second, or in between first and sixth. So the product that we will get here, the product we are getting, two products that we may get, and between the this was the bromine which the CH3 is present over here, and if you will see, if this is the first position I have taken, so between first and second carbon, between first and second carbon, this was the first carbon, this may be the product, and between first and sixth, that would be formed. This will be the product. Two products are formed. Okay, two products are formed, but here you will see this is a stereoselective example of stereoselective reaction where the JetSef as well as non-JetSef product both are formed, but this will be the major product and this will be the minor product. Major, and this will be our minor product that is formed. Okay, so this is about the this one. Now this is we can also see some other example. We can also see some other example where the rate of E2 elimination changes with the substitution. Now if you will see one of the example, let's see this one. This is one of the case. Now they are the two examples. These are the two examples, and if you will see here, then in this example, the elimination can occur. If this is our alpha carbon, this is our alpha carbon, then this is our beta carbon. This is the beta. This is beta, and this is beta. And at this beta carbons, these both at this both position beta carbon, one of the hydrogen, no doubt, that would be anti to this bromine. And here also the one of the two hydrogen that is also anti to the bromine. So we can either remove the beta H from here, or we can remove the beta H from here, or from here. But another substituent which is present is the methyl group, and this methyl group below, this methyl group is above. Now what it is found that one of the reaction is slow and the reaction is fast. So why? What is the reason that this reaction is slower reaction and this reaction is the fast reaction? What is the reason that this reaction is the fast reaction. So that can be obtained. The reason you can find the reason if you will draw its chair form. So let's draw the chair form for it. If I draw the chair form for this, then what you will find? You will find that this bromine is, because suppose this is our first position and this is our sixth position, second, third, fourth and fifth, sixth. In the same way, first, second, third, fourth, fifth, and this is sixth position. So at first position, if you will see, then this bromine is below. Okay, this bromine is below. And at fourth position, suppose this is the first, second, this is third, and this is fourth. At fourth position, this CH3 is down. So you will write this CH3 down. Now, if you will write here the chair form, if you will write chair form for this structure, then what you will find? This bromine, no doubt, same position, and this is the CH3 position which is going up. Now, as this bromine is present, these two bromine are in equatorial position. That's why we cannot see the anti-periplanarity. We cannot get the product until you write it in a flipping form where the bromine is in axial position. So that's why to write the product, we should write it in a flip form. So let's flip it. And after writing it in flip form, what you will get? Okay, so this is now first, second, this is third, this is fourth, this is fifth, this is sixth. And at first you can see the bromine is down. I have written in down form. And at fourth position, this is our CH3. This is our CH3. Okay. Now in the same way, suppose I write the flip form of this, then what you will get? Again, this is our first, second, this is third, this is fourth, this is fifth, and this is our sixth position. So if you will see, then bromine again, first position, this is the first position, okay, and this is the sixth position, second, third, fourth and fifth, sixth. Okay, right. So now after flipping, this bromine comes here, and what you will see is at fourth position CH3 is above. At fourth position CH3 is above. Sorry, here in this case, this CH3 is down. This CH3 is down position. This CH3 is in down position, and in this case CH3 is in up position, like this. Okay. So if we want to write the elimination product, then the hydrogen we have to remove, beta H, we have to remove the beta H, and one of the beta H is present over here, and another beta H is present over here also, another beta H is present over here also. So either this can be removed, either you can remove this beta H, or you can remove this beta H. Okay. In the same way, one of the beta H in this structure, one beta H is present over here, and another beta H is present over here also. So we can remove this one, or we may remove this one. So, but what I have told you, this reaction is fast, this reaction is slow. Reason is this. In this structure, this is going below, this is going below, and that's why at fourth position this is going after flipping, this is going at fourth position, this is going below, this is at upper position, this is going at upper position. Okay, so what you will get, so why this reaction is, this reaction will be fast, so this reaction will be slow reaction, this is the slow reaction, this is the slow reaction, and this is the fast reaction, this will be the fast reaction. So reason is that why this is fast reaction, here you will see the 1,3 diaxial interaction, whereas when this bulkier CH3 group is present at the equatorial position, there is no 1,3 diaxial interaction. Here due to 1,3 diaxial interaction, this is the slow one. So the product that you can get, no doubt the product, the main product that you will get, the main product. So we will get here the hydrogen which is removed, either both hydrogen can be removed from here, this one or this one, both product would be formed. So at first and sixth and first and either you will get this product or you will get the another product that you can get is, this would be the product, two products you will get, but this is faster one. Here also you will get these two products, but this reaction will be the slow reaction due to the 1,3 diaxial interaction. Hope all of you are understood. Thank you.